Hi, Mr.
All right,
Scott.
what's up, folks? How's everyone doing?
Good.
And silence. Awesome. Eddie says hi. Cool. We got a special guest today, guys. That is, you might have to jump so they can see you. There it is. All right, yeah, Deanna's in today. She's completing some work, and instead of popping online, she's actually going to be in class watching this. So that's cool. So we got a guest in today. We're going to be doing a bit of welding. Yesterday we talked a little bit about joint preparation. We failed miserably in that video. That video sucked and I hated it. But today, hopefully a little better. I'm going to try something out. So I've dissected a welding helmet and I've got the lens, and I'm going to see if I can fit it over this potato cam and see if I can get you guys actually seeing some welding here. So this will be cool. What we're doing today is we are going to weld flux core positions 1, 2, and 3. So that's the 1F, the 2F, and the 3F, the vertical. So hopefully I don't suck too bad and we can complete this in a timely fashion and my welds will look half good. I don't do this very often, but it's kind of like riding a bike, except the bike is on fire and everything's on fire, and yeah. But we'll get there. We'll make it happen. We're going to do that for you today. So I tagged up a bunch of joints previously. So we're going to do a couple examples. We're going to use 2 different settings. So we're going to run the 045 flux core, and we're going to run one setting is going to be big. It's going to be 23 volts, 260 inches a minute. That's a smaller one. Then we're going to run 26 volts, 450 inches a minute, and try and do this in a single pass. That's a 3/8 plate, your standard plate. We did those yesterday. Tacked on the ends like we talked about. Smarty size tacks, nothing too big. And yeah, we're gonna see how this all looks and works on the camera. I'm not too sure. We're learning as we go here. GoPro didn't have a power cord, so yeah. Kind of dealing with that. Mr. Lawrence is probably gonna kick this on at some point, or not this, but the extractor that's right over here, and it's gonna get noisy, but we're gonna see what happens and see how this goes. A couple things to remember: turn your gas on. Always turn your gas on. I don't know how many times I've walked by a booth and I hear a weld. I'm like, oh, that person doesn't have the gas on. Pop in there and we got an arrow bar looking weld, right? So if the weld looks like an arrow bar, chances are you don't have adequate gas coverage. The gas might be on, might not have enough. Someone may have backed that flow meter or regulator out. You may not be delivering gas over the weld properly, or it might be coming out the end of the nozzle like it should be, but a breeze could be blowing it away before it covers your weld. So we got to make sure that conditions are good. Obviously in the shop here we're good. The only thing, like that's why I kind of say, 99% of the time in the shop, it's going to be your gas isn't on if you've got that porosity in your weld. That's a big discontinuity. We don't want that in our weld. So I'm going to double check that my gas is on, and we are going to get things happening today. Awesome. Thanks for jumping in, everybody. Hopefully I can get a couple more, but I'm going to start this off. Double check my settings. So I've got things set up here. I'm not welding in the dark booth anymore, so I can't drag this out. I've got some big settings here. 26.2, 452. We're going to drop that down to the lower settings. First, 3 volts. And we are going to go to about 300-ish. Let's see what happens there. So, welding PPEs, your standard stuff. Actually, we're going to drop this here. I looked at my notes, and our speed is going to go 260. So with this, one thing we need to remember is if we're getting worm tracks, we chip off our weld and we got those worm tracks all over it, stick out. Stick out is important. Stick out or contact tip to work distance. 3/4 of an inch is what they recommend. 3/8 is what we recommend for gas metal arc welding. Flux core arc welding, we are going to go with 3/4. I don't know why. There's some science behind it. That's beyond me. I'm just a welder, but I know how to operate these things, and that's what I find works best. So we need to get in our PPE. So I'm going to lose the glasses. We're going to put some safety glasses on. And gloves, good gloves, thicker gloves are best because this is a hot process. I got my shop shirt on, so I don't need a welding jacket. I might put one on if I find that I'm getting spatter with this, but it's generally a spatter-free process. If you got something you like to keep nice, like a fancy new Fitbit, or if you got that bust-down Rolly, we want to take that off. So we want to get those out of here. We don't want that stuff getting damaged. So we'll set those aside. And yeah, your gloves, your helmet. With this stuff, it is very bright, so I like to keep my buttons done up almost all the way. If you have a short helmet and an open collar, you're going to end up with a redneck, literally. Not just, you know, in the more metaphorical sense, but you'll have physically a redneck because this is going to burn you. The UV is quite bright. We talked about shielded metal arc welding being about 10 times as bright as the sun. Gas metal arc welding and TIG being even brighter. So GMAW, FCAW, pretty much the same thing. It's bright. So get yourselves ready. I'm going to set a weld on the table here. I've got my ground clamp hooked up. And I'm going to try and position this. A super bright camera. We can kind of see it there. I'm just trying to see what's going to be best. Terrible. Closer. And then I'm going to tip that camera down and hopefully not fry. That's a little better. Yeah, we'll go with that for now. You won't see me, but you can see the weld. Okay, we're going green, guys. I'm putting this half dissected welding helmet over top the camera. It's an auto dark one. And we're gonna see what happens. We're gonna go with shade 9 so you guys can see a little better. Sensitivity is high and delay is minimum. Those are all those controls on the back. That one for you, for those who don't know, is where we keep the battery. So this will work even without a solar pickup. Solar just aids in the longevity of the battery. So you guys are going green now. We're gonna plug you guys in. All right, and we can still. Angle, we're going to weld right down that joint there. We're going to put one in the bottom and then one against this side and then one against the edge here. You're chipping it off and cleaning it off entirely every single time. We don't want any of that flux in our weld because that could get trapped inside the weld and end up being a discontinuity that we don't want. So we really want to avoid those weld defects and discontinuities. And this is how we do it. So we're going to clean it nice up. Up nice and see what happens when I weld this thing. Hopefully it turns out okay. If not, we're going to learn from our failures and move on. Failing is okay. Okay, that you'll be able to see it well. Yeah, you'll be able to see that. Yes. Cool. Except for when we're going. Let's do it. So hopefully that looked okay on there. That was pass one. We're going to clean it up, have a look at it. So it's really hard to see, but it's not the nicest work I've ever done, but it looks okay. We're not quite. So we are going to pass fill it up so we can spatter anything like that. All right, so that was pass two. When I did that, I didn't just look at my puddle of my weld. What I did is I went to that edge of the plate, made sure my puddle was filling that top edge. That edge of weight, backfill it. Letting it backfill it to avoid undercut. That's pretty important when doing welds like this. Let's strip it off and see how it turned out. So this is actually looking pretty nice. We'll see if we can get it in there.
Mr. Scott.
Somebody saying something, or is that why you want?
I wanted to tell you that you keep cutting in and out really bad, like as you're talking.
Just like this?
No matter where you are, you cut out.
All right, so that's a problem. That sucks. What I might do is yeah, what we're doing is just finish up that second pass. If it's on there, see how that goes. It's going to cut out quite a bit. I'm just going to weld and show you the end product.
Okay.
More. All right, hopefully that camera can kind of figure itself out. It's a little overexposed right now, but we did okay. We ended up with a half decent looking. I can't really see the screen, but yeah, right there, half decent looking weld. Overall, not bad. That's 3 passes, and that was with the 23 volts and 260 inches a minute. I did bump the voltage up just a few points, so I'm at 23.5. I'm going to show you guys a single pass version of that with 26 volts, 450 inches a minute. push you guys back under the lens. See if this works. You guys can't quite see that. We'll put it down a bit. That'll be better. All right, one and done, hopefully. See how this goes. So that was pretty hot. But I think we're gonna have it hopefully. So when these are hot, they're really hard to chip. I actually cool it off, and the slide will pretty much pop right off in the slide bucket, and it turns out pretty nice afterwards. So that, hard to see, but turned out pretty decent. Nice and flat, full, everything we wanted in one pass. So if we're doing that with gas metal arc welding, that would take at least 3 passes with no 3-5 wire, and it would take a lot of time. So I love FluxCore because we can really speed up production by running bigger numbers of units. So that's one of the main advantages FluxCore has over gas metal arc welding. So it's just a production speed that you can get. That's pretty decent weld, done in one shot. You don't even have to go back to any two sides. So I could show you the 2F. Same as the 1F pretty much. I don't really need to. What I'm going to do is I'm going to show you guys the 3F. So we're going to do uphand vertical flux core welding. We're going to run the 23 volts and 260 inches a minute, 250, 260, and we'll see how that goes. So I'm going to reset this a little bit. So hopefully everyone could see that. You can't really see much detail on this, but I know there's undercut. I know that for a fact. I can see it before I even ship it. So I'm going to dunk this, get it cool, that slag will pop off, and show you guys the results. So let's get this lens off for a second. Let this thing just figure itself out. All right, there. It was just a side-to-side motion. Once this camera figures its life out, we can hopefully get some detail on that. And it doesn't seem to be happening. But long story short, what we have here is a bunch of undercut. I didn't hold long enough on the sides. So what I'm going to do is I am going to flip this over and weld the other side, holding a little longer on the sides. I kind of do that little mini triangle I was talking about, that inverted triangle. I do that a little bit. Maybe we can get some detail now. It's not going to show the detail, but fairly smooth, but there is some undercut. So I want to fill that in. So we're going to hold it just a little bit longer on the next one. Behind the lens again, so you're not just staring at a super bright screen. Do this, put it more in the middle of the screen, and go over there. So when I'm doing this, I keep my gun almost flat. Maybe a few degrees inclination, kind of slightly pointing up. But when I move up the weld joint, I try and keep it as level as possible. I don't do this as I come up. That's going to increase your stick out and create some stuff we don't want in the weld. So keep it as flat as we can, and the side to side and up for the weld. So take two. Hopefully it's better. So you can see it's still glowing. It's quite a hot process. Back of my hand is nice and warm. Plate is half red. Camera kind of picks it up, even though it's pretty washed out color-wise. Overall, a very hot process. Might be a little bit better. It's still undercut there. But on future, it's going to be better. So let's dump that, see what happens. So, not terrible, not super even, but they're still hard to see. The camera can't really pick it up. A little bit of undercut on the sides. But these are the first two I've done in a long time, so I'm not really too concerned. Yeah, you pick it up again fairly quick. A couple inconsistencies in the weld itself, but overall pretty easy. And you guys can see how much weld we got done in a minute of welding. So that's why I love FluxCore. This is great. And we got a fair amount done here in a very short period of time. So that is the cool part, I guess. I quite enjoy FluxCore for that. Definitely not as portable as other systems. You know, you got your power source, wire feeder, your gas bottle, just that stuff. But if you're running shielded metal arc welding, it's much more portable, easier to use. That's why you see it in all the welding trucks. But this stuff is great. I really enjoy it. I'm hoping that when we get back to class, we can run some stick welding for a bit. Those who haven't tried this can hopefully try that as well. And that is pretty much it for today's show. That quiz should be open and available for you. Tomorrow we are going to go through the process of the 1G FluxCore weld. So that is the groove weld. That's done with a gas metal arc welding root, a GMAW root. So solid wire for the root, and then the fill and pass or filling cap are done with weave stringers. So we're gonna just take that and a little bit of a side-to-side action. That's in the flat position, so it's just gonna lay right in there real nice. And we'll fill it up that way. And the fill and cap are FluxCore. So FluxCore does not work well for the roots. It's just not something you wanna ever do. But if you can figure that out and figure out how to do it, please let me know, because I sure can't. And standard practice in the industry is gas metal arc welding root. Yeah. Without the cover of the camera and slightly covers the mic. Okay, yeah, hey, that's a good point. Maybe I'll find a different way to film this. We'll see how it goes. This is new for everyone here, right? So we're just kind of seeing how it goes. Good thing is I seem to be making progress every day, getting a little bit better in one respect or another. I had a big fail for half the beginning of the video. I'm in multi-screen. So if I'm trying to record this, which I am, right there was a big fail. But no, we live and we learn. And I should have given you all the information you need for that 5-question quiz. I've hit all those points. Yeah, so let's complete that. And thanks for joining us, guys. Drop your name in the chat just so I have you for my attendance. And we are good. You guys are good to go once you drop that name. Thanks for attending. Have a good day. And see ya.